All right, so we are going to be working with triangles and quadrilaterals and a whole bunch of shapes so we can find the area of them. So starting off, we are going to start with a parallelogram. And the formula for an area of a parallelogram is base times height. Ooh, what in the world just happened there? Computer has a mind of its own. So with parallelograms, it's always just going to be base area times height, just like a rectangle, because if you were to cut this little triangle off, you could actually scoot it over here and it would make it a perfect rectangle. So an important thing is that the height of the parallelogram is measured from the segment perpendicular to a line containing the base. So whenever you're looking at it, make sure you're looking for that little right angle symbol so that you can make sure it's your true height. So with this, we want to find the area of the parallelogram. So area is base times height. It's always a good habit to just write the formula that you're using. So then our base is going to be 22 and our height is going to be 10. So we'd have 22 times 10, and 22 times 10 is 220, and this would be feet squared since it is area. Boop, good there. So if you are not given your length specifically and maybe you have to solve for something else, we want to find the base of a parallelogram with a height of 56 and an area of 168. So if you use that formula, you just plug in what you know. And I need to X out of that. Boom, gone. Okay, so area would replace the A, so I'm going to put 168. And then I don't know my base, but I do know my height is 56. So then I will come through and divide by 56 so that it cancels out on the right. And 168 divided by 56 gives me a base of 3 yards. And this is just going to be straight yards because it is a length, not an area. So then to find the area of this parallelogram, you might notice that it doesn't actually give us the true height because our height would be this right here. But since we don't have that measurement, we have to figure out what it is. So this is where knowing Pythagorean theorem comes really, really handy because since this side is 34, I know this is also 34. And then I have 2 of my 3 sides of my right triangle right there. So using Pythagorean theorem to find our height, I would have 30 squared plus h squared equals 34 squared. So then 30 squared is 9,000, or no, I did 300 squared, oops. 900, there we go. So 900 plus h squared equals, 34 squared, which is 1,156. And then when we subtract 900, we get that h squared, and I ran out of space. H squared equals 256. So then if I take the square root of 256, that gives me a height of 16. So now that I know my height is 16, now I can actually find the area of this parallelogram. So area is base times height. My base is going to be whatever it sits on. So in this case, it's 11. So 11 times 16. And 11 times 16 gives us 176. And so then our units would be millimeters squared. Okay. So our next shape is triangles and trapezoids, and they are very, very similar to each other. So area of a triangle is 1/2 your base area times your height, and area of a trapezoid can be written one of 2 ways. You can write as 1/2 base 1 plus base 2 times height, or base 1 plus base 2 times height divided by 2. Regardless, you are going to have to divide by 2 for both of these. And another way you can write the area formula for a triangle is base times height divided by 2. So, ooh, sorry. So, notice that the letters in the formula correspond to the letters in the shape itself. Sorry, I apparently learned how to, or forgot how to not choke on my spit. So, if I wanted to find the area of this lovely trapezoid to the right, I'm going to use the formula area equals base 1 plus base 2 times height divided by 2. If you want, you can label your picture. This is base 1, base 2, and our height. Keep in mind it does not matter which base you say is base 1 and base 2 because it gives you the same answer regardless. So this gives us base 1 is 11, base 2 is 17, and height is 7. So 11 plus 17 divided by, or times 7 divided by 2. So 11 plus 17, is 28. So this gives us 28 times 2 divided by 2. Ooh, not times 2. What am I doing? Okay, 28 times 7 divided by 2. So then 28 times 7 gives me 196. And that divided by 2 gives me 98. So then because this is area, it's going to be feet squared. Okay? So if I want to find a missing measurement for this trapezoid, I'm still going to be using the same formula. So area is base 1 plus base 2 times height divided by 2. And we want to find base 2. So we know that area is 231, so I can replace A with 231. And then my base 1 would be 23. And my base 2, I don't know yet, so I'm just going to write B2. My height I know is 11, and then that's divided by 2. So this strategy is going to be a little bit different for this one simply because you are actually solving an equation. So you're actually going to undo all the stuff that's happening to that B2. So let's go with purple. I'm actually going to multiply by 2 right off the bat. That way it cancels out on the right. So 231 times 2 gives me 462. So then that becomes 462 equals 23 plus base 2 times 11. And then to move away from that big set of parentheses, I'm going to divide by 11 because then on the right, that'll leave me with just 23 plus base 2. And on the right, or on the left, 462 divided by 11 is 42. So now I've taken care of all of the ugliness that was with that big set of parentheses, and now I can just solve. So that came up here. So then to finish this off, we're going to subtract by 23. And we get that the base 2 is 42 minus 23, 19. And since this is a base, it's just going to be 19 millimeters. Okay. So if I wanted to find the area of this triangle, I still need my base and my height. But notice that my base, I don't know. So there's a really big hint in here. That right triangle tells you that you can use Pythagorean theorem. So we would have 12 squared plus b squared equals 20 squared. 12 squared is 144, and 20 squared is not 2, 400. There we go. So then we would subtract by 144, and 400, if I can type, minus 144 is 256. So then square root of that is 16. So I know that my missing base is 16 thanks to the Pythagorean theorem. So now to actually find my area, I'm going to have area equals base times height. My base is 16 and my height is 12. So then 16 times 12 gives me 192. And this would be meters squared. Ooh, wait! Did you find my mistake? I was all sorts of wrong formula. Oopsie. So since this is a triangle, it's actually going to be 1/2 your base times your height. So 1/2 of 16 times 12, which makes this 1/2 of 192, or 192 divided by 2, which gives us 96. I thought that number seemed strangely humongous. There we go. So it's 96 meters squared. And hopefully you caught that before I did it wrong. So just make sure the formula for area of a triangle is 1/2 base times height. So make sure you are multiplying by 1/2 or dividing by 2. So now we move on to diagonals to rhombuses and kites. So rhombuses and kites, the diagonals are perpendicular, and the diagonals of a rhombus bisect each other. So we know that the area of a height, of a rhombus or a kite, is 1/2 of your diagonals multiplied together, or you can also write it as 1/2 diagonal 1 times diagonal 2 divided by 2, whichever one you like. So with this kite, we have diagonals of 12 and 18. So my area is going to be my diagonals divided by 2. So my diagonals are 12 times 18 divided by 2. That 18 does not look like an 18. Okay, that's mildly better. So then 12 times 18 is 216. And 216 divided by 2 is 108. So then our area would be 108 centimeters squared for this. And I actually remember to divide by 2. Woo! Small wins. All right, so then if I want to find diagonal 2 of a kite where diagonal 1 is 14 and area is 238, I'm going to still use the same formula and then just plug in what I know. So I know my area is 238, and I know my diagonal 1 is 14, but I don't know my diagonal 2. So I'm going to divide by 2. So then to solve this, I'm going to multiply both sides by 2 so that it cancels out. So 238 times 2 gives me 476, which is 14 times diagonal 2. So then if we divide by 14, we get that diagonal 2 is 34 inches. Okay, and if you wanted to check it, you just plug that in. 34 times 14 divided by 2 gives me 238, so we are correct. Okay, so that's just a quick overview of that step. So we're going to quickly go over some of the other things that we have to cover for this. So first and foremost, we have a circle. And a circle is the locus of points in a plane that are a fixed different distance from a point called the center of the circle. Okay, circle. Okay, so the circle is named by this symbol, looks like a little circle with a dot, and its center. So if I say circle A, I'm talking about this circle over here. So the irrational number pi is defined as the ratio of the circumference to the diameter, or pi equals circumference divided by diameter, which, as you all know, is 3.14159, and it just kind of continues forever. So solving for C gives us the formula circumference equals pi times diameter, and also this diameter is 2 of your radius, so C can also be 2 pi r. So when you are working with circles, just know you have 2 formulas for circumference that may come into play, and then you have your 1 area formula. One way to remember this is chocolate pies are delicious, apple pies are too. So just random thing that might help you remember which one is which. So, okay. So if I wanted to find the area and circumference of circle K, I know that my diameter is 6, circle K. So circumference would be pi times the diameter, and in this case, my diameter is 6. And since we want it in terms of pi, I'm just going to leave it as circumference equals 6 pi. And that would be inches because circumference is just a measurement, not a squared. Okay, so then if I want area is pi r squared. Our radius is going to be half of that, so it's going to be 3 instead of 6. So 3 squared, and 3 squared is 9, and since we're keeping it in terms of pi, it is 9 pi inches squared. Okay? Now, the pi key gives you the best possible approximation for pi in your calculator. So this is a big thing. Always wait until the last step to hit that button and round. Okay? Always wait. It is your last step that you should be doing is pushing that button. So if I have the area of a circle whose circumference is 12 pi, remember circumference is 2 pi r or pi times diameter. So if my circumference is 12 pi, I'm replacing the c with 12 pi and solving for r. So I'm going to divide by 2 pi because the pi's cancel. And then 12 divided by 2 is 6, and the pi still cancels. So I know my radius is r. So then, because of that, I can find my area, because that's pi r squared, and my radius is 6. So then I get that area is 36 pi. And, we do not have a measurement, so this is just units squared. Okay? All right, so polygons. With polygons, they are, as you know, shapes. Can be 4-sided, 10-sided, 32-sided, just kind of depends on what you're given. So, with that being said, regular pentagon or regular polygons are all the same length. So regular polygons same side lengths. So if I had, let's say, a 4-sided polygon, that would be called a quadrilateral. Doesn't matter if it's a trapezoid or a square or anything like that, it's just a quadrilateral. 5-sided is a pentagon. 6-sided is a hexagon. 7-sided is a septagon or a heptagon. One's Latin, one's Greek. And I've heard both people use both of them, so might as well know both. 8 sides is octagon. 9 sides is nonagon. 10 sides is decagon. And then anything above 10, you just call it a 12gon, or a 15gon, or an 18gon, etc., etc. So, the center of a regular polygon is equidistant from its vertices. So because it is equidistant from the vertices, it just is smack dab in the middle of that shape. So then the apothem is the distance from a center to a side. So let's say I had a pentagon. My apothem would be from the center to the middle of a side with a right angle, like that. So then a central angle of a regular polygon, a central angle of regular polygon, has a vertex at the center and its sides pass through consecutive vertices. Each central measure of a regular n-gon is 360 divided by n, or the number of sides. So if I have 5 sides, 360 divided by 5, each central angle would be 72 degrees. So we have regular pentagon DEFGH and a center of C, apothem BC, and a central angle of DCE. So we have apothem BC, which is right here. Then we have central angle DCE, which is this angle right here. Okay, so the area of a regular polygon is going to be 1/2 times the apothem times your perimeter. So just keep in mind with perimeter, you're going to need to actually solve for that. So we have a regular octagon with a side length of 10 feet and an apothem of 8 feet. So using that formula, I'd have 1/2 times apothem times perimeter. By the way, if you prefer, you can also write it like this, where it's apothem times perimeter divided by 2. But my apothem they gave me is 8, and then my perimeter, because my side lengths are 8, perimeter is going to be 8 times my length. So number of sides times your length. So I know my perimeter is 80. So then when I multiply all of this out, 8 times 80 divided by 2 gives me 320 feet squared. Okay, so then moving on down, with 13 we want to find the regular pentagon, and we know that its apothem is 4.85. So boop. So if I want the side length, I need to know what the heck is this measurement. But you notice that's not really very helpful right now because I don't have any of that information. But you do have a way to solve it. You notice that it looks like a little right triangle in here. One way to find your side length is to use Pythagorean theorem in this case. So I have an A, I don't have a B, but I have a C. So 4.85 squared plus b squared equals 6 squared. 4.85 times 4.85 gives you 23.5225, and 6 squared is 36. So when you subtract from 36, minus, going crazy, 23.5225, there we go. So when we subtract that, we get that b squared is 12.4775. So then when you take the square root, you get that b is 3.53. Now, something to keep in mind is that 3.53 represents just this little pink section, not the rest of it. So you actually have to multiply this by 2 so that you can get the full length of the apothem, which would give you 7.0647. I'm just going to go out a few extra decimal places. So with that, I can find my perimeter because I have 5 sides, and each side is 7.0647. Okay, so when I multiply that by 5, I get my perimeter to be 35.3235. So then my apothem is 4.85 like they gave me. My perimeter is 35.3235, and I am dividing by 2. So if I multiply those together, and by the way, I have not rounded at all on my calculator. I'm still letting it do all of the work. So when I multiply those numbers together and then divide by 2, I get that my area is about 85.659 So if I rounded to the nearest hundredth, I would say 85.66 meters squared. Okay. So that covers all of our area, but just to quickly kind of go over, some of the rules we have with quadrilaterals and all of this. So with quadrilaterals, you know it is 4 sides. And actually, let me just draw a little line. Boop. So quadrilateral is 4 sides. You know this, squares, rectangles, all sorts of stuff. So with a kite, your diagonals are perpendicular. And one pair of opposite angles are congruent. Okay. Now let's put this in a pink box. Boop, 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 boop. Okay. So then a parallelogram, this one's going to be purple. So with a parallelogram, opposite sides are parallel and congruent. Opposite angles are congruent. Oh goodness, there's a lot of stuff with this. Consecutive angles are supplementary, diagonals bisect each other, and one pair of sides are parallel and congruent, which we already have. Okay, so then trapezoids will make blue. Trapezoids have one set of parallel sides. They don't get much for trapezoids. Okay, so, what in the world? There it goes. Okay, so then rectangles, you're probably a bit more familiar with. With rectangles, they have 4 right angles. And your diagonals are congruent. Okay. So then with a rhombus, you will end up with 4 equal sides. And your diagonals are perpendicular. And one diagonal bisects pairs of opposite angles, which I'm not going to write because it'll take me a hot minute. But, boop, those are some rhombus rules. And then last but not least, we have our ever so lovely square. And a square is like a rhombus and a rectangle merged together. Because, my M does not look like an M. Make it look like an M. A square is a rhombus and a rectangle because squares have 4 equal sides, just like a rhombus, and the diagonals of a square are perpendicular, just like a rhombus. But on top of that, the square also has 4 right angles, which a rhombus does not always have 4 right angles, and the diagonals are congruent, which is not always the case for a rhombus. So the homework is a worksheet, so you can access Schoology to get the worksheet if you happen to lose your copy. Otherwise, happy working. Don't forget to like and subscribe.